Our last video in 7.4, we're going to take our combined functions. Remember when we added, subtracted, multiplied, or divided? And let's talk about their domain. Now, if x is in the domain of f and it's in the domain of g, then it should also be in the domain of them added, subtracted, multiplied, or divided together. So, if x is not in one of those domains, well then it's not in the combination of their domains either. Let me show you what I mean by that. Example number 3 says, if f of x is 5 over x, and g of x is 2x minus 6 over x plus 1, find the domain of them added, subtracted, and even multiplied. Well, if f of x is 5 over x, what's f's domain? Are there any restrictions? Well, yeah, I notice that I have a variable in my denominator, and I notice that I have a restriction there because if x was 0, then there would be a 0 in my denominator. So I know that my domain for f is anything except for 0. What about g? Well, I notice that g is also a rational function. I have a denominator, and there's going to be a domain restriction anytime that denominator equals 0. And so what x is going to cause that denominator to equal 0? Well, it looks like my domain for g is anything except for -1. So if my domain for f has a restriction of 0, and my domain for g has a restriction of -1, well then adding, subtracting, or multiplying those has that same combined restrictions of 0 and -1 together. So that means my domain of adding them, f plus g, subtracting them, f minus g, or multiplying them would be the combination of the two domain restrictions. So x can be anything except for -1 or 0. Or I can say my domain for the combined functions f plus g, f minus g, f times g is -infinity to -1, -1 to 0, and then again from 0 to infinity, making sure not to include those two numbers though in my domain. Again, if there are restrictions in the individual domains, there are also restrictions in their domains combined. Okay? All right, it's a little bit different when we have division, because division is going to cause us to have a possible denominator, right? And so if you look at example number 4, if f of x is x squared minus x and g of x is x plus 2, let's find the domain of f divided by g. Well, if f is my x squared minus x and g is my x plus 2, and I go to divide them, didn't I just now create a rational equation with a denominator? And as soon as we have that denominator, we know that there can't be a 0 in that denominator. So what domain restriction do we have now when we start to divide these two functions? Well, it looks like here, x can be anything except for -2. So my combined domain for these two, even though f by itself didn't have any domain restrictions and g by itself didn't have any domain restrictions, as soon as I divide them and I create that denominator, there is a domain restriction with the combined functions. X can be anything except for -2, or I can say -infinity to -2 and then -2 to infinity. So just making sure that you're looking out for those denominators and those domain restrictions as soon as you have a denominator. All right, why don't you try a few here? Why don't you try a few algebraic combining of our functions, f plus g of x, do an f minus g of 3, and then practice doing one of those domain problems. So I have 3 try-it problems for you. I'd like you to pause the video. I'd like you to try them, making sure that you understand before you move on to the homework and the Chapter 7 tests. All right, for try-it A, f plus g of x means that I can do f of x plus g of x separately. F of x is my 2x plus 3, plus g of x is my 4x squared minus 9. When I go to combine those, keeping my x's there, because that's what this says, I can keep my variable, I end up getting the combined function of 4x squared plus 2x minus 6. All right, what about f minus g of 3? This time, my answer is just going to be a number, because after I'm finished subtracting them, I can plug in a 3. Or I can do f of 3 minus g of 3 and get the same answer. F of 3 minus g of 3, plugging in a 3 wherever I see an x in my f function, plugging in a 3 wherever I see an x in my g function, and then making sure I subtract those two values. For f of 3, I got 9. That was a 6 plus 3. For g of 3, I ended up getting 27. Now I can subtract those two values, f minus g, and I ended up getting negative 18. Hopefully you did too, no matter which way you did it, right? All right, let's talk also about finding domain, and finding domain specifically of f divided by g. Well, if I write f divided by g, it looks something like this. I've just now created a rational function with a denominator, and I know that my denominator can never equal 0. So if I set it equal to 0 and solve, this looks like a difference of squares factoring. So it looks like I can factor it into an 2x minus 3 and a 2x plus 3. If I set each of those equal to 0, then I know that x can be anything except for 3/2 and negative 3/2. So my combined function of f divided by g has a domain of all x's such that x just cannot be positive or negative 3/2. Or I can say negative infinity to negative 3/2, negative 3/2 to positive 3/2, and then again from positive 3/2 to infinity, just making sure that I don't include those two values.